Imagine you're a basketball coach training a rookie player. Every time they take a shot, you observe the result, analyze their mistakes, and help them adjust. So this process of learning from mistakes is exactly how a neural network improves over time. So today, we're going to break down backpropagation step by step using a simple math story. So even if you've never seen these formulas before, you'll get it by the end. By the end of the video, you'll understand how neural networks take inputs, process them, make decisions, and learn from their mistakes through adjustments. Think of this as a journey into the mind of AI, where machines get smarter with each iteration. Welcome to today's lesson on backpropagation neural networks. So think of this as the brain behind artificial intelligence, allowing computers to learn by mistakes, just like our basketball player. This technique is the foundation of deep learning, powering applications like speech recognition, recommendation system, and even self-driving cars. So without backpropagation, AI wouldn't be able to refine its predictions, meaning errors would remain unchecked. It's a continuous feedback process that makes AI more effective over time. Let's dive in and see how this works step by step. So how does a neural network makes a decision? First, it takes inputs like a player's stance, jump, and angle. Multiplies them by weights, as you can see in this formula, which represent importance, and then adds a bias, a little push to adjust predictions. Each input carries different importance, just like in basketball. Stance might be more crucial than hand positioning. The hand or the sum of these weighted inputs is then fed into an activation function, which determines if the neuron should be active or not. So this step helps the model distinguish between patterns and make informed choices based on the data. So in our cases, we are using the ReLU or the rectified linear unit activation function to introduce the nonlinearity, and this helps the network learn complex patterns. So let's break this formula down further. What I mean is this formula, and let's have this breakdown. So every input multiplies with a weight. So this represents how much that feature contributes to the final output. So think of this like giving points to different shooting techniques. Some moves may contribute more than others. So for example, if jump height xi is crucial and the weight wi assigned to it is high, then its impact on the shot outcome is significant. So multiplication ensures that each input has an appropriate influence on the decision-making process. So without this step, the network wouldn't be able to distinguish which features matter most for prediction. So let's have this. Now, in this case, we sum up all these contributions and add a bias B. So bias acts like an additional push to make sure the neural network doesn't rely solely on inputs. So think of it as a slight nudge from the coach, making sure the player adjusts their shot slightly if needed. So summing the weighted inputs gives us an initial decision score before activation. So this ensures that even if some input features are small, they still contribute to the final decision. So adding bias prevents the model from always outputting zero when inputs are zero. So here's where it gets interesting. So we apply the ReLU with a rectified linear unit, which is like a judge deciding. So if the sum total is positive, we keep it as it is. If it's negative, we set it to 0. So think of this as the referee saying, if your shot is good, take it. If it's bad, don't even try it. So this function helps filter out unnecessary information to ensure that only strong signals are passed forward. So without ReLU, our network wouldn't be able to model complex data effectively. So great. Now we have the player that has taken the shot, but what if they miss? So this is actually the story behind this one. So all of these different steps can be summarized into that, and that's actually the question. So what if it misses? Well, what if, for example, the space between the ball and the ring is too wide, or it's just too thin? So backpropagation is the process of learning from mistakes. So we calculate how much each weight contributed to the error and adjust accordingly. This step is like analyzing each movement of the player. Did they jump too low? Was the angle off? So in this case, by using calculus or what we call derivatives, the network figures out how much to tweak each weight to perform better next time. So this is what allows neural networks to continuously improve over time. By constantly adjusting these weights, the player gets better over time. So the neural network does the same. So it fine-tunes itself to make better decisions in the future. This process is what we call gradient descent. So in this case, the model takes small steps to minimize the error, just like an athlete refining their technique with each game. The neural network iteratively updates its weights to improve predictions. The more it trains, the smarter it gets. So this is how AI learns from past data and make accurate predictions. The whole system works like a team strategy. So every small improvement leads to smarter AI predictions in things like self-driving cars, voice recognition, and even medical diagnosis. The goal is to make sure each layer learns useful representations of the data. Each layer takes in information, processes it, and refines its understanding. Think of it as different coaching drills, each designed to improve a specific skill. So the final output represents the best possible decision the AI can make based on what it has learned. So we started with inputs and applied weights, used value, and fine-tuned our predictions using backpropagation. So this is how machines learn from mistakes and get smarter. Neural networks adjust themselves over time, ensuring they make decisions as they process more data. So AI is just like humans. It learns through mistakes and experience, corrects its errors, and gradually become more accurate. So this is the secret behind modern deep learning. Now you understand how machines learn, so go ahead and explore the world.